In the previous videos, we graphed polynomial functions by using the leading coefficient test to determine the end behavior of a polynomial function. We also calculated the x-intercepts, the y-intercepts, and some additional points to graph the function. And we used the maximum number of turning points and the symmetry to graph the function. In this video, I'll show you how to graph a polynomial function by using a table. In other words, we are going to plug in some x values and see what y values we get. And with these ordered pairs, we can graph the polynomial function. By the way, you can use this method for all kinds of functions. Note that with this method, we do not always find the exact turning points of a polynomial function. In other words, if we want to determine the exact relative maximums and relative minimums, we have to use calculus. In general, we can say that graphing a polynomial function is a matter of experience and depends on which kind of polynomial function you have to graph. So let's say we have the polynomial function f of x equals x cubed plus 2x squared minus 2x. The best and easiest way is to start with x values around the 0. So let's start with 0 for x. F of 0 equals 0 cubed plus 2 times 0 squared minus 2 times 0. Zero cubed is 0, 0 squared is 0, times 2 is 0. And 2 times 0 is 0. So when we plug in a 0, we get a 0 as an output. In other words, 0, 0 is a point on the graph. Let's try 1 for x. F of 1 equals 1 cubed plus 2 times 1 squared minus 2 times 1. 1 cubed is 1, 1 squared is 1, times 2 is 2, and negative 2 times 1 is negative 2. 2 and negative 2 cancel each other out, so what's left over is 1. So 1, 1 is also a point on the graph. Let's plug in 2 for x. F of 2 equals 2 cubed plus 2 times 2 squared minus 2 times 2. 2 times 2 is 4, times 2 is 8. 2 squared is 4, times 2 is 8. And negative 2 times 2 is negative 4. 8 plus 8 is 16, minus 4 is 12. Two, 5, 6, 7, 8, 9, 10, 11, 12. We see that we can't graph the point 2, 12 on our xy plane because our xy plane goes only to 4. Let's try the negative x values, negative 1, negative 2, and negative 3. F of negative 1 equals negative 1 cubed plus 2 times negative 1 squared minus 2 times negative 1. Negative 1 cubed is negative 1. Negative 1 squared is 1 times 2 is 2. And negative 2 times negative 1 is 2. So 2 plus 2 is 4, minus 1 is 3. What about negative 2? Negative 2 cubed plus 2 times negative 2 squared minus 2 times negative 2. Negative 2 times negative 2 is 4, times negative 2 is negative 8. Negative 2 squared is 4, times 2 is 8. And negative 2 times negative 2 is positive 4. Negative 8 and 8 cancel each other out, so what's left over is 4. Let's plug in our last x value, which is -3. So f of -3 equals -3 cubed plus 2 times -3 squared minus 2 times -3. -3 cubed is -27. -3 squared is 9 times 2 is 18. And -2 times -3 is +6. 18 plus 6 is 24, and 24 minus 27 is -3. So the point -1, 3 is on the graph. -2, 4 is on the graph. And -3, -3 is also on the graph. I can tell you that our function is going to look like this. Which makes sense because a function of degree 3 has maximum 2 turning points. If you want the positions of the turning points more precisely, you have to plug in more values for x in these areas to get more y values. If you like my videos, like, share and subscribe. Thanks for watching and happy learning everyone.